Hello students, in this video we are going to start a new chapter, ratio and proportion. Ratio and proportion are the two expressions which gives the relation between any two quantities. Let's take the ratio first. What is ratio? Ratio is the comparison. Ratio is the comparison between two similar quantities. Ratio is the comparison between two similar quantities. Let's take one example of weight of person A and person B is 20 kg and 30 kg respectively. That means A person weighs 20 kg, B person weighs 30 kg. So kg, the weight is the similar quantity here. 20 kg and 30 kg weight is the similar quantity. We are comparing those two similar quantity of person A and person B. We may compare the height of person A and person B, where height becomes the similar quantity. Here you have taken the weight as the similar quantity. Then the ratio between A and B, the ratio is denoted by the two dots called is to. The ratio between two quantities or two persons is taken as is to. It is denoted by two dots. So A is to B equals 20 is to 30. This is the ratio between A and B persons in case of weight. So we can divide the ratio by same number, or we can multiply the ratio with same number. The value doesn't change us. Here I have done by dividing both the numbers by 10. By dividing both the numbers. Both numbers are 20 and 30 here. Dividing them by 10, we get the ratio of A and B as 2 is to 3. So this is the ratio between A and B person in case of weight. Weight is the similar quantity between two persons here. So that is the ratio. Once again, the definition is the comparison between two similar quantities. In this example, I have given weight as the similar quantity between person A and person B. One person is having 20 kg and other is 30 kg. When you are comparing the weight, we get the ratio A is to B equals 2 is to 3. Let's come to the proportion. So what is the proportion? Proportion is the relation between the change in one quantity to corresponding change. You may observe here the corresponding change in the other quantity. If one quantity changes, the other quantity also changes. But in case of ratio, if A becomes, weight of A is 40 kg, need not be B 30 or 35 kg. It need not be changed. The quantity of the weight of A is independent, weight of B is also independent. But in case of proportion, the change in one quantity causes change in other quantity also. That type of relation is called as proportion. The relation between change in one quantity. If one quantity changes, the corresponding change will appear in the other quantity. This is called proportion. There are two types of proportion. One is direct proportion and other is indirect proportion or inverse proportion. Direct proportion and indirect proportion. Indirect proportion is also called as inverse proportion. Let's take one example for each. Direct proportion first. So what is direct proportion? When value of one quantity increases or decreases. The first quantity value increases or decreases, then the corresponding increase or decrease. You may observe the order here. First is increase, second is decrease, is observed in the value of other quantity. Then they are said to be in direct proportion. That means if one quantity increases, the other also increases. Arrow mark says both are increasing. If one quantity decreasing, the other also decreasing. That means both are in the same direction. If one quantity increases, the corresponding change in the other quantity is also increased. If one quantity decreases, the corresponding change in the other quantity also decreases. This is the direct proportion. Let's take simple examples to explain direct proportion. If the cost of 10 volt is rupees 20, then the cost of 30 volts is rupees 60. The cost of 10 volts The cost of 10 volts is rupees 20. Then the cost of 30 volts is rupees 30. As the number of volt increases, the cost also increases. There is rise in both the quantity, the cost and the number. If there is increase in number of quantities, there is increase in cost of quantity also. You may observe here the cost of volt increases, that is directly proportional. The symbol is just like alpha. The symbol directly proportional to number of bolts. You should read like this: cost of bolt increases is directly proportional to number of bolt increases. In this way we can explain the direct proportion. Let's take one more proportion of decreasing. In the second example, I have giving you both the quantities are decreasing. When first quantity decreases, second quantity also decreases. Let's take the example. If cost of 10 volts is rupees 20 and the cost of 5 volts become rupees 10. And as the number of port decreases, the cost also decreases. Here it is clear, as the number of bolts decreases, the cost also decreases. Hence, this is also direct proportion. You may observe here, the cost of bolt decreases directly proportional to number of bolt decreases. Both the case decrease. In the first example, both the case increase and increase. That means both the quantities will be in the mode of increasing or in the mode of decreasing. That type of proportion relation between two quantities is called as direct proportion. Let's take second type, that is indirect proportion or inverse proportion. When the value of one quantity increases or decreases, observe carefully, when the value of one quantity increases or decreases, then the corresponding decrease or increase, should observe here, decrease or increase is observed in the value of other quantity, then they are called indirect proportion. The first quantity increases but second quantity decreases. In the second case, after OR, the first quantity decreases but the second quantity increases. That means they are in opposite direction. If first quantity increases, the second quantity decreases. They are in the opposite direction. This type of relation is called as indirect proportion or inverse proportion. Let's explain with some example. In the example number 1, the RPM, the speed, rotating speed of a wheel. The rotating speed of a wheel is called as RPM. The rotating speed RPM, rotation per minute, of a wheel is 10 with dia 200. 10 centimeter dia is 200. The 10 centimeter is the dia of the wheel. If this is 10 centimeter, then the RPM is 200. The RPM of wheel with 5 centimeter is 400. If wheel is still small, that means if dia is 5 centimeter, then the RPM becomes double, that is 400. It means if dia increases, the speed decreases or RPM decreases. So this is the indirect proportion. Second example, a car takes 2 hours to cover a distance of 100 kilometers with a speed of 50 kilometers per hour. A car can take 2 hours to cover a distance of 100 kilometers with speed of 50 kilometers per hour. The car covers the same distance, that is 100 kilometers, same distance, in 4 hours with a speed of 25 kilometers per hour. What happens here? When the speed increases, the time taken by the car decreases. When the speed decreases, the time taken by the car increases. That is, time is inversely proportional to the speed. This is the 1 by alpha, inverse proportion we have to indicate by 1 by alpha. Here in RPM case also it is 1 by alpha. So in this way we can explain the relation between any two quantities. They may be directly proportional, they may be indirectly proportional, but we can explain the relation between similar quantity in case of ratio. So ratio and proportion both are almost similar, but we have to observe that in similar quantity we take ratio, in different quantity we are taking the proportion. So in this way we can solve the different problems of finding the ratio and proportion of different problems. In the next chapter, in the next class, I am going to take you some basic problems of solving the ratio and proportion problems. So thank you. Thanks for watching.